Kanaz Kovner. For my exhibition, I made a science video that you're watching right now. I hope you like it. Let's get sciencey! One problem, I don't know anything about science.
So he read a bunch of books.
Alright, I'm ready. Out of the 7,936 books that I totally read, and was not just 5, one really interested me. It's static electricity and electricity. You slide down a plastic slide and touch someone. You get a static shock. You pull off a hood and the static electricity makes your hair stand straight out of your head. It's not magic, it's because of static electricity. To understand static electricity, we have to learn a little bit about what all the stuff around us is made of. Everything is made of atoms. Imagine a rock. Keep dividing it half and giving one half away. Do that over and over, and eventually you will get to a piece so small you will not be able to see it. It is still a piece of the same rock. If you are able to divide that many more times, you get something called an atom. But if you are able to divide an atom, it will not be a rock anymore. Everything around us is made of atoms. So what are atoms made of? The center of an atom is a nucleus. Inside a nucleus is 2 tiny particles called protons and neutrons. Circling the nucleus are even smaller particles called electrons. The protons are positively charged, the electrons are negatively charged, and the neutrons have balanced charges. All things have positive or negative charges. Opposite charges, positive and negative, attract each other just like magnets. A neutral object is when positive and negative charges are balanced in an object. Most objects are neutral. Static electricity is when there's more of one charge than the other. A charge can build up on the surface of an object unless they find a way to release it into another object. When you're learning about electricity, electrons are the most important thing because electricity is made when an electron of an atom is separated from the atom and forced to move. It just finds another atom and shoots towards it, kicking the other electron out of its atom, and that goes on over and over. Other things can also conduct or make electricity, like potatoes and lemons. Yes, you heard me right. I said potatoes and lemons. To prove it, I will show you an experiment that I made. You can try it at home, but be careful. This experiment is very simple. All you need is lemons. I have 4, but you don't need 4. You need zinc. It doesn't need to be a stick. Copper coins, multimeter, scissors, and wires. First, cut a small hole in all of the lemons, just big enough for your copper coins to fit in. Then poke the other end of the lemon so this bar of zinc could fit in. Before you insert the copper coins and zinc into the lemons, wrap a wire around 3 of them. Now put the zinc in the hole that you made. Now attach this end of the wire to the zinc on a different lemon. Make sure it's touching the zinc. So now get your multimeter, set it to whatever you want. And then put this end onto the copper coin and wrap this end onto the zinc. Now, I set it to 20 dCV, and right now it's getting 3.68. This happens because lemons contain citric acid, and citric acid contains many electrons in them. And when these metals, copper and zinc, are inserted into the lemon, it takes the electron out of the citric acid. When this happens, the zinc produces electrons. When the two metals are connected, the extra electrons are attracted towards the copper, and from there it goes to the digital multimeter.